Hello. My name is Emily.
And my name is Kevin.
Today we are going to be discussing grief.
Well, that sounds depressing.
It is definitely not a pleasant emotion, but Kevin and I are going to lay a foundation explaining why it is an adaptation.
To summarize the main points of our video, we will begin with an introduction to grief, discussing its cost as well as the neuroscience behind it. Then we will delve into attachment and unpack the deep relationship between attachment and grief.
Next, we will discuss psychological pain and its relationship to grief, and end with describing why grief is an adaptation through signaling theory.
So, to get us started, it is important to understand how costly grief can be.
Grief is often thought of as an extremely negative process, and it has a stigma associated with it as being weak and even pathological.
An educational foundation in California actually put a price tag on the annual cost of grief in the workplace and found it to cost $75 billion.
That is a lot of money. Grief is also known to significantly interrupt a person's ability to perform daily tasks, to participate in social activities, and to seek out romantic partners.
Grief has also been shown to increase mortality rate, susceptibility to illness, visits to physicians or other health professionals, suicidal ideation, and possibly even suicide.
Then, if we are considering grief's cost from an evolutionary standpoint, ruminating about the dead is extremely costly because it is wasting time and energy from thinking about something else.
So, as we have discussed, grief can cause a lot of pain and suffering.
Why waste time, energy, effort, resources? Why, in other words, grieve for a social bond that can no longer compensate such dedication?
Grief appears to be universal. Everyone grieves across cultures and around the world.
Clearly, grief is something that has been selected for. You do not learn how to be sad or how to grieve, even though you may learn what to grieve for or what to grieve about.
In the remainder of the presentation, Emily and I will lay out a foundation that will explain why we believe grief has been selected for as an adaptation for humans and some non-human animals.
In order to understand how grief could be considered adaptive, it is important to consider its relationship with attachment.
Our hypothesis is based on the idea of grief being an adaptation of attachment.
Wait, what is an exaptation?
Exaptation is a term used in evolutionary psychology to describe a trait that has been co-opted for a use other than the one for which natural selection has built it.
Oh, so basically a trait can evolve because it originally served one purpose, but subsequently it may come to serve another.
Exactly. One example of this would be the feathers on birds. Feathers' original adaptation was for insulation, but then they became an exaptation for flight.
Since we are arguing that grief is an exaptation of attachment, let's delve into some attachment theory. The first person we will discuss for attachment is William Blatz, who created a precursor to attachment theory, which he termed security theory. He posited that security was the primary goal for humans. An important concept in his theory is the importance of a stable mother during early years of development. This is a theme that continues with the growth of attachment theory. According to Blatz, achieving security depended on creating trust with a caregiver, which allows the person to have a secure base to explore and take risks.
Next, we will discuss John Bowlby, who actually coined the term attachment theory in the 1960s. Similar to Blatz, Bowlby believed that childhood development depended heavily on the child's ability to form a strong relationship with at least one primary caregiver. The goal of attachment, according to Bowlby, is physical or psychological proximity. A strong attachment to a caregiver provides a necessary sense of security and foundation. Without this relationship, a great deal of effort and stress is expended in the search of stability and security.
Mary Ainsworth built on this foundation of attachment with her famous strange situation procedure. Ainsworth's studies involved a broad range of children with varying attachments to their caregivers, and the strange situation procedure was used to measure and classify a child's attachment to their caregiver. Ainsworth identified three main attachment styles: secure, insecure avoidant, and insecure ambivalent/resistant. She concluded that these attachment styles were the result of early interactions with the mother. Overall, the dynamics of attachment can be compared to a homeostatic control system. Attachment is all about the regulation of safety. Through the development of attachment, the child learns to regulate safety. Exploration for a child is a risk. With attachment, the child is able to explore, knowing they have their caregiver to fall back onto if necessary. Therefore, attachment theory can be considered a homeostatic process of exploration and vulnerability.
Attachment behavior has also been observed in non-human animals. One example of this is with Konrad Lorenz's work with imprinting.
In an experiment, Lorenz separated a nest of goose eggs into an experimental group and a control group. He took the experimental group to raise apart from the mother, but left the control group with her. The experimental geese only met Lorenz, not their goose mom, when they hatched, and proceeded to attach to him as their primary caregiver.
To test this hypothesis about the hatchling-mother bond, he marked the two groups and put them together under a box. Sure enough, when he brought in the mother goose and lifted the box, the control group waddled back to their mother, but the experimental group came to him. Lorenz named this phenomenon of certain birds learning who their parents are as filial imprinting.
This experiment shows attachment being a universal phenomenon across animals. Although the degree of attachment may vary as well as its lasting effects, I would predict that attachment is important for many animals.
So how can we investigate the mechanistic properties of attachment and how it relates to grief while also proposing an animal model?
Here we propose that the prairie vole is a good animal model to investigate grief and attachment. The prairie vole is a monogamous species of rodent that pair bonds for life, much like humans. This picture shows the side-by-side behavior that researchers look for when studying prairie voles. Despite their cuteness, they can also be ferocious.
In a paper by Sun et al. 2014, investigators induced pair bonding in experiments by allowing the prairie voles to mate for 24 hours to form a strong bond, and then separating them. Let's introduce some key concepts present in the study before analyzing their results.
One of the tests used in the study is the elevated plus maze. The elevated plus maze is important for investigating anxiety-like behavior in animals. Rodents have a tendency to be well hidden in order to escape the grasps of aerial predators and other predators. When the animal is not anxious, they display less anxiety-like behavior and spend more time in the open arms than the closed arms. Animals that are more anxious will want to be less exposed and more hidden, therefore spending more time in the closed arm. Another test used in the study is the light-dark box, which has similar goals to the elevated plus maze. The box is comprised of a well-lit open space and a dark room separated by a small hole. If the animal is displaying less anxiety-like behavior, it will spend more time in the well-lit open space than in the dark room.
The affiliation test opposite sex conspecific is when a male and female prairie vole are placed in the same cage. Computers are then used to keep track of their affiliative behaviors or side-by-side behaviors, or aggressive behaviors, which are chasing and biting. The resident intruder test is similar to the affiliative test. However, the only difference is that instead of females and males, two males are placed together in the same cage to see if there's any affiliative behavior or any aggressive behavior. The partner preference test is when prairie voles are placed into 3 different cages that are connected by 2 tubes. The male prairie vole is placed in one of the cages. The partner prairie vole, or the prairie vole that it's been mating with for 24 hours, is placed in another, and a stranger prairie vole, or one that it hasn't been exposed to, is placed in the other cage. Then, observers record the amount of time that males spend with the partner or the stranger. This is quantified by their side-by-side behavior or their aggressive behavior.
Now we are going to introduce some important hormones analyzed in the experiment. Oxytocin is released in response to a variety of experiences and stimuli and under various circumstances, both positive and negative. Attachments and social bonds also form under many different kinds of conditions. Many studies leave little doubt that oxytocin plays a central role in the social behaviors that lie at the heart of the human experience of love. It is likely that vasopressin plays a major role in the emotional and visceral experiences. Studies show that polyamorous species, like the prairie vole, can be made monogamous with a higher concentration of vasopressin. Now we are going to discuss the results of the study.
For the elevated plus maze and light dark box test, they allowed males and females to mate for 24 hours and then separated half of the partners for 4 weeks. In the elevated plus maze and the light dark box experiments, the researchers evaluated the male's response to bond loss. After allowing the male and female prairie voles to mate for 24 hours, they separated half for 4 weeks, while the other half remained together. During the elevated plus maze, the males spent overall more time in the closed arms. This indicated that they were exhibiting more anxiety-like behavior. The results were similar in the light dark box test, in that males spent more time in the dark than in the light, again exhibiting more anxiety-like behavior.
For the affiliation test, the separated prairie voles affiliated more with stranger females as seen by side behavior or body contact, rather than attacking behavior. For the resident intruder test, separated prairie voles showed more affiliative behaviors than the paired prairie voles, as seen by more nose interactions as well as anogenital sniffing.
For the partner preference test, paired males that were not separated displayed a preference for their familiar partner over stranger females. For the males that were separated from their partner preference was observed after 2 weeks of partner loss but eliminated after 4 weeks of partner loss.
In regard to the immunohistochemistry analysis, the hormones related to bonding in the paraventricular nucleus and the supraoptic nucleus, which are responsible for secreting vasopressin and oxytocin, showed an increase in secretion of the love hormones in the brains of the prairie voles that were separated. However, they also showed distress as a result of the prairie voles being separated. This is shown by the increases of corticotropin-releasing hormone in the paraventricular nucleus. CRH is responsible for the release of cortisol, or the stress hormone.
Now that we have talked about the mechanistic properties of grief and attachment, let's delve into psychological pain being a component of grief.
In a narrative by David Biro in 2010, Biro interviewed Dan Bento, a man who had recently lost his youngest daughter to cancer, after years of watching her agonizingly slow and painful death. Bento describes the psychological pain he experiences regarding his daughter's death, stating, "They say passing a kidney stone is the worst pain you could ever have. They're wrong. Sure, it was bad. I remembering whimpering like a baby in the emergency room, but it was a joke compared to this pain, which never passes. It just keeps on going and eating me up inside. I still feel it now, intense as ever, 10 years later."
This is precisely what scientists are discovering. Naomi Eisenberger and her colleagues at UCLA have recently developed a clever model of psychological pain that can be objectively studied. Normal subjects played a video ball tossing game while their brains were monitored by a functional MRI. When the subjects were excluded from the virtual game, they experienced distress that correlated with increased blood flow to the anterior cingulate and insular cortices, exactly the same pattern of activation that would be seen when being stuck by a needle, or physical pain. The greater the social distress generated, the more active these affective pain centers became. Studies done on saddened and grieving subjects produced similar results in a study by Gundel in 2003.
We propose that psychological pain is an imperative part of the grieving process. Psychological pain serves as a cue for the person experiencing the grief. This allows them to know that a part of their homeostatic control is altered. Psychological pain can also be a signal to others, aiding to signal the grief the person is experiencing. This idea of grief being a signal to others will be explored in greater detail in the next section.
Now that we understand grief's mechanisms as well as its relationship to attachment, we can discuss why Emily and I believe grief is an adaptation for both human and some non human animals.
Weingard et al. 2014 provides signaling theory as a solution to the immense costs created by grief and as an explanation for grief as an adaptation.
Signaling theory is used to analyze the logic of animal communication. In regards to grief, it argues that grief is a method of communication.
One premise of signaling theory is that grief is a hard-to-fake signal of a person's current level of commitment to a group and or their tendency to form strong bonds with other individuals.
Wait, what is a hard to fake signal?
A hard-to-fake signal is one which is nearly impossible to imitate and therefore must be considered honest. For example, the extravagant feathers on a peacock could be considered a hard-to-fake signal.
Oh, I see. So, since humans are profoundly social species, it is imperative to be able to distinguish between good and bad social partners. Therefore, honest signals of an individual's propensity to form strong commitments are beneficial to the receiver of the signal, who can then use the information to choose loyal allies.
Exactly, and therefore grief is an honest signal of current and possible future levels of commitment. Another important component of signaling theory is social selection theory, which is the competition between individuals for socially mediated resources, including social partners along with sexual selection, and is another important subtype of natural selection.
So, the logic of signaling theory is as follows: 1. Humans live in large and complicated social groups. 2. Humans are exceedingly cooperative, even with non kin. 3. However, the possibility of cheating and or non-reciprocating was and is ever present. 4. Because cheating was possible, humans selectively choose to form alliances with good social partners. 5. This aspect of choice creates a pressure on humans to display pro-social tendencies.
6. However, the display of prosocial tendencies can be faked by cheaters. 7. This leads to the evolution of cognitive mechanisms to detect cheaters. 8. This, in turn, leads to the development of costly or hard-to-fake signals of cooperative intentions and propensities. 9. Because grief is costly and hard to fake, it signals one's propensity to form non-calculated social commitments. And 10. Humans who displayed prolonged grief response were preferentially chosen by social partners and rewarded with status by social groups.
Now that we have an understanding of attachment as well as a proposed mechanism of grief as an adaptation, we will discuss our hypothesis. Many believe grief to be a byproduct of attachment. If the byproduct theory is correct, then grief itself has no benefits. However, as we explained earlier, grief appears to be a beneficial form of communication.
Kevin and I hypothesize that grief is an adaptive trait that is an exaptation of attachment. We hypothesize that grief has evolved to provide individual social benefits, and we predict bereavement behaviors characterized by grief allow other socially networked non-human animals to also experience grief as an adaptation.
It is important to delineate which non-human animals have the capacity to grieve. Emily and I propose a few traits that are necessary for non-human animals to possess in order to grieve.
These include the ability to recognize an individual, the ability to distinguish between life and death, and finally, the display of bereavement behavior.
In summary, this video discussed the costs of grief, attachment's relationship to grief, psychological pain, and grief as an adaptation.
Thanks for tuning in. We hope you enjoyed learning about grief as an acceptation of attachment.